All right, so for the last example, this involves Newton's law of cooling, and let me just review what that is. If U of t is the temperature of a heated object at time t, and this is going to approach the room temperature, or the temperature of the surrounding medium, which is capital T. And so we use this formula because hopefully capital T and U sub 0 will be given to us, hopefully, and we might have to figure out what this K is before we do anything else. And that's exactly what happens on the last example. We have a pizza pan that's removed at 5 p.m. from an oven whose temperature is 450 degrees Fahrenheit in a room with a constant temperature of 70 degrees Fahrenheit. And after 5 minutes, the temperature of the pan is 300 degrees Fahrenheit. At what time is the temperature of the pan 135 degrees Fahrenheit? Okay, so right away, we know that the initial temperature, U0, is 450. The room temperature is 70. We know the difference, we can compute that to be 380. So right away, we know that U of t is in the form of 70 plus 380 times e to the kt. Okay, our job is first to find out what this k is before we do anything else. So, fortunately, we're given this other piece of information, that after 5 minutes, the temperature of the pan is 300. Okay, so this basically says that U of 5 is 300. Okay. So this tells us that 300 is equal to 70 plus 380 e to the k times 5. Okay, and now we solve for k. Well, this is an exponential equation. We want to isolate this e to the k5. So we first subtract 70 from both sides. Okay, and that gives us 230. Divide both sides by 380. And then we can see that, or if this says that k times 5 is the exponent we raise e to get this fraction. So k times 5 is equal to the natural log of 230 over 380. And we can see that this fraction definitely simplifies to 23 over 38. So k times 5 is this logarithm, so k is 1/5 times the natural log of 23 over 38. Okay? All right. Now, if you can, hold off on plugging this into your calculator and risking round-off error. And let's see what we're trying to do. We're trying to find what time, we want to find when is the temperature 135 degrees. Okay, so in this case, U of t is equal to 135, and we want to find out what t will be. Okay, so 135 is equal to 70 plus 380 times e raised to our k, which we now know it's k is 1/5 natural log of 23 over 38 times t. Okay. Seems like an ugly expression, but we know everything is a number except for t. Once again, we can subtract 70 from both sides, and we'll get 65 equals 380 e raised to this number. Then we divide both sides by 380. And 3 over 38 times t. And then we will see that t, well, we can take the log of both sides. And then this is 1/5 natural log of 23 over 38 times t. And then we just say this is just one number. We divide by this number. So we get that t is natural log of 65 over 380 divided by 1/5 log of 23 over 38. Okay, this is approximately 17.58. Okay, so the time, that's 17.58 minutes after we take it out of the oven. We took it out of the oven at 5, so this is going to be 5:17 or 5:18 p.m. Okay. And notice that we save ourselves a lot of grief by, these numbers look a little ugly, but it will save us round off error if we just write this in this ugly form and then plug it in our calculator. Okay, great.